Hey guys, welcome back. This is 3.4 part 2. We're just really continuing what we did last class and essentially doing the same thing that we finished with. The only difference now is sometimes we'll have irrational roots and I'll tell you how to deal with those when they come up. Alright, first of all though, we're just going to start the same way that we always do. We're trying to find the zeros of this function. So I'm going to first check how many positive real and negative real roots I should expect, or zeros. Okay, so here I have positive, starting from positive to negative, it's one sign change, two sign changes, three sign changes. That means I have 3 or 1 positive real root. That's good news because that means I'm at least guaranteed to have 1 and then maybe 3. Let's see what f of negative x is. So 2x to the 4th stays the same, then it switches to negative x to the 3rd power. Negative 33x squared stays the same. This is going to switch to negative 56x and negative 20. So starting off positive, then it went to negative and stayed negative the whole way. So we know there's exactly 1 negative real root. Okay, so I have 1 or 3 positives and 1 negative for sure. Then we're just going to go through the usual thing. Looking at my n value, it's 20. So the possible p's are things that divide that. So p is equal to 1, 2, 4, 5, 10, or 20 plus or minus, yeah? And then q, on the other hand, is equal to only 1 or 2. Alright, so p over q is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Actually, you know what I'm going to do is I'm going to write this down on the bottom left corner because I'm going to be checking a bunch of these things, so I'm just going to leave this as reference for myself. These are the things that I can check. So p over q is equal to plus or minus 1, plus or minus 2, plus or minus 4. And I know these guys are pretty long. That's why we only have a short assignment today, because well, it's not really short because these problems take a while. Okay, so these are all the values divided by 1. Now I do the same thing over 2, so I get a half. 2 over 2 is just 1. 4 over 2 is just 2, so that's done. Plus or minus 5 halves. 10 is 5 and 20 is 10, so I got those already. Alright, so those are my possibilities. Now I'm just going to make some space for myself. I know what my possible roots are on the bottom. I'm just going to start taking guesses. Now before we would start with the smallest value, just 1, because that's the easiest to deal with. But instead of doing that, I'm just going to look at my numbers and try to make an educated guess of what might be a good choice from among my options. Okay, I know I have 1 or 3 positive ones, so let's start with looking for positive ones first. Let's see, if I stick in a 1 here, it looks to me like 1, this will be 2, 3, plus 56 minus 30. Oh, actually one might work. So let's check out 1. So here's 1, 2, 1, negative 33, 56 minus 20. The way I kind of get that is that if it's gonna work, if I plug in 1, it should be about 0. And so I kind of estimate if I stick in 1 here, is that gonna be somewhere around 0? Let's see. So 2 comes down. 1 times 2 is 2. 2 plus 1 is 3. 1 times 3 is 3. Negative 33 plus positive 3 is negative 30. Negative 30 times 1 is, this is negative 30. Right, so negative 30 plus 56, that's going to be 26. 26 times 1 is 26, and negative 20 plus 26 is 6. So, okay, that did not work. All right. So 1's out. Let's see, if I was to stick in a negative 1, what would happen? Well, this would be negative 33, that would be negative 56. That looks like a really large negative number, and it's not going to be, and this is also negative, so negative 1 is not going to work. What about positive 2? Positive 2, this would be 2, 4, 8, 16 times 2, which is 32. Another positive number. Okay, 2 seems reasonable choice, so let's try 2, see what happens. bring the 2 down. 2 times 2 is 4. 4 plus 1 is 5. Times 2 is 10. Negative 33 plus 10 is negative 23. Times 2 is negative 46. Plus 56 is 10. Times 2 is 20. And then 20 minus 20, negative 20 plus 20 is 0. So, okay, this works. That means 2 is a factor. Okay, awesome. And not only is it a factor, but this is the polynomial that's left over here. It's going to be, this is a 2x cubed plus 5x squared minus 23x plus 10. All right, so let's continue on from here. We know 2 is one of the zeros. So let's make a note of that on the side here. Zeros. 2 is one of them. Okay, and we'll leave some space for the other ones. And we're going to restart this question now with this cubic polynomial. So that makes our life easier to deal with. And once we get down to quadratic, then we can just stick it into the quadratic equation, yeah? Okay, so we have 2x cubed plus 5x squared minus 23x plus 10. All right. So I'm going to do the same thing. I know there's, let's see, there's 2 or 1 positive roots, 2 or 0 positive roots remaining. I know there's a negative one remaining for sure from the last, what's left over from the first part of the question. Let's look at what my possible P over Q's are. P is 1, 2, 5, or 10, things that divide the 10, yeah? And then Q is just 1 or 2 again. So on the bottom, P over Q's, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, and then 1 over 2 plus or minus 1/2, plus or minus 5/2, and those are the only things. I know it's not going to be positive 1 because we checked that one already. And I know it's not going to be 2 because, well, actually, no, it could possibly be 2 because it's possible that you have a root that repeats itself. We know 2 is a root once, but it could be a root again. All right, let's see. What should we try? What should we try? If I stick in 2 again, it's going to be 2, 4, 8 times 2. This is going to be 4, 20. Minus 23 times 2, 46. That seems a little small to me. So I'll maybe try something else. Let's try, see, negative 2 is going to be negative. Let's try negative 2. And I don't know, we're just going to try stuff. Negative 2 times 2 is negative 4, and that's 1. That's negative 2. That's going to be negative 25. That's going to be positive 50. So, no, way off. No, that's definitely not 0. Okay, so moving on. Let's try 5s, I guess. Let's try the 5. Actually, let me try positive 2 again, because it's possible that was a root more than once. Okay, so bring the 2 down. That's 2. 2 times 2 is 4. Plus 5 is 9. Times 2 is 18. Negative 23 plus 18 is negative 5. Negative 5 times 2 is negative 10. Oh, it's 0. Okay, sweet. So it actually turns out that 2 is a root 2 times. So the zeros are 2 and then 2 again. So we'll say 2 is a double root because it appears more than once. It appears double times, twice. Oh, shucks. I didn't mean to erase that because I wanted to work with that guy. So let's rewrite that. 4 is 9, and that's negative 5. Okay, so this is my remaining polynomial. 2x squared plus 9x minus 5. And now that it's a quadratic, we can just stick what's remaining into the quadratic equation and it's going to spit out our answer. for the remaining two zeros. Okay, so let me just copy that down at the top. All right, we're going to stick that into the quadratic equation. That's negative b plus or minus the square root of b squared, which is 81, minus 4ac, which is negative 5, all over 2a, which is 2 times 2. And then from here, we're just going to simplify. That's negative 9 plus or minus the square root of 81 minus 4 times, or 2 times 5 is negative 10, times 4 is 40, and it's negative negative, so plus 40. Okay, all over 4. All right, that's going to be nice because it turns out that's negative 9 plus or minus the square root of 81 plus 40 is 121. And 121, the square root of that is just exactly 11. Okay, so we're over here. Negative 9 plus or minus 11 over 4. Okay, so I take the positive side first. Negative 9 plus 11, which is negative 9 plus 11 is positive 2 over 4. And negative 9 minus 11, that's going to be negative 20 over 4. And then simplify that. 2 over 4 is a half. And negative 20 over 4 is negative 5. All right, sweet. So I found my zeros, half, and you notice that these were some of the options that we had listed earlier as well. So that makes sense. It's possible you have things that are not options. If you have irrationals, but we'll talk about that when those pop up. Okay, so my zeros, 2 appear twice, so 2 and 2, or you can say 2 with multiplicity 2. We have 1/2, and we have negative 5. That's it. I'm just going to cut off this one. These questions do just one at a time today.